My name is Evan McGee, and this is a talk about deploying global RTC infrastructure with Docker. We're going to cover some of the same things that our last speaker was just talking about a little bit from a slightly different angle, and so you'll get to that in just a minute. But yeah, I'll try to keep it kind of fast and moving, and we'll make sure that everybody can get out of here and get to the cocktail hour pretty quick. So let's just go. Okay, so yes, here's me, Evan McGee, SignalWire. I'm the CTO and founder, and the fonts are messed up, but that's okay. There's my stuff on all the things. Come find us over at SignalWire. So real quick, what is SignalWire? We are a technology company focused on software-defined telecom, right? What we're here to do is to build kind of a giant global elastic communications infrastructure layer that you can use to build your applications on top of. We're designing some very simple-to-use APIs that you can do to consume everything from text messages to phone calls to video web RTC, all the things you want to do to build in there. We're here to do it. We're founded by the people behind the FreeSwitch open source project. If you've used that ever in any of your applications, it's used by a lot of different things, everything from the Ring video doorbell all the way to like Amazon Connect and that kind of stuff. That's us. The CEO was the founder, Anthony Mansale, and yeah, come over and check it out sometime. FreeSwitch is a great project as well. So what have we done, and why did we do this? Well, one of the issues with getting real-time communications moving, I think we all know, is trying to scale these kind of things. You download FreeSwitch or any kind of other similar style thing, Janus or Corrento or whatever, and it's difficult to scale, right? It's hard to necessarily get that into a position where you can make that something that's globally accessible on a big footprint right away. You might have users in Asia, you might have users in the North American continent. You want to kind of keep things moving. So we founded SignalWire to build a big elastic communications infrastructure using FreeSwitch. So how do we do that, right? We use containers, we were just talking about. And just as a quick show of hands, who here actually uses Docker and containers like in production today? Okay, great. So I'll just breeze right through this. This was in case no one knew what we were talking about, right? So we all know why they're great, right? Baking a Docker image like he was just talking about is fantastic, lightweight, really easy to deploy. You get immutable images. They're just lovely. We all love them. That sounds great for one computer, right? But then what do you do about end computers, right? This is where Kubernetes and kind of Docker Swarm come in. You're going to need some kind of orchestration framework. In order to get these containers to scale everywhere, in order to have them actually be resilient and stable, you need something to make this all happen, right? This is what Kubernetes was founded to do. It's also what Docker Swarm was founded to do. So you kind of have two real options. I know there's also Mesos and a bunch of other stuff as well, but I'm going to focus on these two right now because in my mind, they're kind of the two that fulfill kind of the same core premise. Now, we just heard a lot about Kubernetes, which is great because Kubernetes is a fantastic platform. You know, it doesn't matter really which one you choose, but you do probably need to choose one. If you want to have any kind of architecture that is stable or something that is easily scalable and manipulatable, you're going to want to choose one of these orchestration frameworks. So just pick one and get building. We chose Docker Swarm. Why did we do that? Because it's pretty much the non-standard choice, right? Everybody goes for Kubernetes because they see all the dials and bells and whistles, and they're like, I want to use all of that. Well, it turns out all of that comes with a lot of additional complexity, right? It's a lot of complexity on Kubernetes, setting it up, running it. It does move fast, as one of the last commenters just said, right? The API feature sets are not necessarily the most stable, at least they weren't a couple years ago, and you really have to kind of keep track of the overall community. Docker Swarm is a much simpler subset of these features. It is baked into the Docker community engine, so you don't have to really worry about it. The company takes care of it. It was horribly unstable until about the 17.0 release. And I will ask anyone who works for Docker to come explain to me why it was so terrible. But since then, it has become actually extremely stable. And it is a very, very simple orchestration framework that just does what it does and it gets out of the way. It does everything you might need. It does ingress load management balancing. It does, volume storage, all the very simple things. And it is extremely fast to set up. So I kind of put this up here as an example of how to actually set up a swarm. And it takes two commands. It's two commands to actually get the thing up and running. You have two VMs. You start, and you basically init the swarm over here, right? You basically like turn it on. Say Docker Swarm init, advertise address, whatever you want. It gives you a token. You go onto a different node. You type the token in there, and boom, you're done. And right there, you have your swarm is up and ready to go. That comes with inbound, like I was saying, inbound load balancing. It comes with statefulness and health checking and everything kind of built into it. All using a very consistent, very easy to monitor API and eventing system. So I would say if you're looking to get started with one of these large orchestration frameworks, give Swarm a look, because I do think that it might solve your subset of problems immediately. And if it doesn't and Kubernetes has some features you need, then please dig in and try it. But understand that when you're deploying Kubernetes, you're actually committing yourself to a much heavier technical task. And if you're just experimenting or trying to get it done, this is an easy way to go. This just shows like 3 nodes, like London, New York, and Los Angeles. But if you're doing that, here's some tips and tricks, right? This applies to both of them. Let's say you're deploying things in the global cluster across the world. You're going to have a lot of problems here, right? You need to make sure that in any of these things, you have a bunch of masters. The way this works is you have a bunch of masters, right? And like an odd number of them, so like n+1, so you have like 3, 5, 7 masters that kind of all talk to each other. Those are very sensitive to latency. Make sure you keep those close together. Like you can have all your masters in like the same, AWS or GCP, sort of split them between regions or whatever the nomenclature is for your given cloud provider, but then make sure that they're actually somewhat nearby because those are sensitive to latency to keep the split brain from happening. If you're doing global, you're also going to have high latency between the different nodes. The nodes of like the actual different nodes of the workers talking to each other. So on Swarm, you're going to want to look at the thing called the dispatcher heartbeat. That's the thing that actually says, oh, I have a node in Southeast Asia that's timing out because I can't reach it fast enough because the round trip latency is too high. Same thing as kind of the node eviction timeout in Kubernetes. And there's a bunch of other settings in there. Keep track of that because the actual internode latency is going to cause you problems down the line. And then you're going to want to encrypt all your service communication. Part of one of the reasons of using these is that you can use any resource to run your sort of meta cloud. If you're using Kubernetes or you're using Swarm, one of the best things is that you can use multiple providers and abstract away the underlying infrastructure layer so you're not just tied to AWS. You're not just tied to Google or DigitalOcean or something else like that. You are then transmitting things across the internet all the time publicly, so make sure you encrypt it. Docker Swarm does come with encrypted VXLAN overlay networking, so you can actually just turn that on, and you have your own private internal network that's entirely encrypted that you can just then send normal HTTP traffic over if you need to. But that takes me to this part, which is really make sure that the reason why you're doing this is so you can use any resource, right? Part of the thing is that if you really want to reach a global scale of RTC, you got to have a very wide footprint, right? You can't have round trip times from India to Europe. You can't have round trip times from Europe to the US. It's just never going to work. You must be everywhere. And there is no excuse to not be everywhere at this point. There are commodity cloud and commodity data centers all over the planet. And if you're not already using them, you should start using them as soon as you can. Our goal at SignalWire is to have a 50 millisecond footprint where anywhere you want to talk to us, it's 50 milliseconds to the closest real-time node. So anytime you're doing communication, if you're talking to somebody down the street, it's 50 milliseconds to the near one. And we have currently the red locations are our current POPs around the globe, and the blue ones are where we're going to be expanding to try to increase that footprint. So we're not there right now, but our goal is to get there. And they just, a good point is that Azure just opened up their South Africa data center. I think it's in Johannesburg. We were there within, 72 hours. So why not, right? Don't tie yourself to a single cloud provider. If you can, from the beginning, just be cloud agnostic. People like to tie their services to things like AWS's infrastructure or GCP specifically. If they have different tasks, that's great. We use Lambda for a lot of fun things. Here's a list of a bunch of the ones that we've looked at or just kind of bringing them up. They all have good and bad things, right? And you've got to validate all of them yourself. You can look at Azure, you can look at DigitalOcean or Vultr or Scaleways or AWS, whatever you want to do. Whatever you want to use. I throw a jab at AWS because I'm from Seattle originally, but I love those guys. And leverage them all. They all have different amazing things that they're good for, and some of them can be from a business perspective. You can save bandwidth on some of them, right? A good example here is that for like Google, for instance, and a lot of them, free inbound bandwidth, very little outbound. Well, let's say you're generating just a crap ton of metrics everywhere. You're in North America, you're in South America, you're all over the planet, and you're just generating data. You can shove that up into a GCP region, not pay for the ingress on that, process it all. So a good example here is Kafka, just sucking up data from everywhere, right? And then doing stream processing inside the GCP region, and then just exporting just the results. So suddenly your outbound bandwidth there back to clients and like that is just a minuscule version of the inbound torrent that's coming in. And by using multiple providers, you can cherry pick who sends data, where the real-time stuff goes. You can just set all that up. I mean, DNS, all these kind of things can help you route these information streams around, and let you really just customize your infrastructure to solve your business use case. Because at the end of the day, we're building this stuff to try to enable people to build their own applications, and we're trying to run businesses and figure all of this out. And so keep in mind that by using multiple providers, you can really accelerate the growth of your company. So yeah, whoops, wrong way. So yeah, and the goal is to build cool stuff. And so what are we doing about that? Well, one of the cool things we're building is that we just built, and it's coming out in beta right now, is a SignalWire and Agora PSTN phone connector. Right, so basically you can get a phone number from SignalWire, you can call in, and that will then terminate that phone call directly into your Agora conference. Same thing with WebRTC on our side. You can kind of come in through a bunch of different viewpoints. Point being that we're trying to give global accessibility from the telephone legacy networks into kind of the new age. And that's actually in beta as of right now. If you go to SignalWire.com, you can sign up for a space. You can find anybody like me or anyone in a SignalWire t-shirt walking around and ask us for beta access to that. But that'll be going probably generally released later this month and into next month. But we're happy to have anyone jump on board because we want to help push this stuff forward as fast as we can. But yeah, so I'm Evan McGee again, CTO and one of the founders of SignalWire. If you have any questions, let me know. I know everyone's itching to get going. So thank you for paying attention. Have a great rest of the evening.